Hello, everyone, welcome back. This is Easy Learn AI. In our last lecture, we explored Perceptron. Today, based on Perceptron, we'll delve into the learning algorithms of Perceptron. Perceptron learning algorithms are relatively simple but form the foundation for learning algorithms in deep learning models, so we'll take it step by step. Before diving into artificial neural network learning, let's briefly touch on what ANNs do, usually represented by circles and lines. Here, circles represent artificial neurons or nodes, and lines represent connection weights, connection strength, or simply, weights. The essence of what an ANN does is, based on a certain input, after calculation by the network, if the output says dog, that's good, but if it says cat for this input, then we need to train the network. Training the network essentially means adjusting the connection weights to get the correct output, which is what neural network learning is all about. Today's Perceptron lesson, and future lessons on CNN, RNN, and even ChatGPT, all ultimately revolve around changing the connection weight values. So today, we'll see how connection weights change in a perceptron, through a simple example. To aid understanding, we'll implement a perceptron to predict the weather. For instance, if it's cloudless and the wind is gentle in the morning, it's likely to be a clear day, but if it's cloudy and the wind is strong, it's likely to rain. To simplify the problem, let's design a perceptron that takes two inputs. The two conditions for predicting the weather are the amount of clouds and wind. The amount of clouds can be represented between 0 and 1, and the wind strength can also be represented between 0 and 1. Therefore, on a day with strong wind and many clouds, there's a high chance of rain, while on a day with gentle wind and fewer clouds, it's likely to be clear. We collect real instances of clear and rainy days, compile them into numerical data, and call this compilation a dataset. Now let's input this data into the perceptron. We'll assign random values to each connection strength, calculate the sum of the product of each connection strength and input value, and put this sum into an activation function defined as a step function. Since the calculated value of 0.36 is below the threshold of 0.5, the perceptron output is 0. The actual value, ground truth, should be 1, but the predicted value is 0. The difference between the actual value and the predicted value is called the error. Adjusting the connection strength of the perceptron to minimize the difference between the actual value and predicted value is what we call learning. The perceptron learning algorithm is as follows. If the error is 0, then current input value times error times learning rate all becomes 0. No error means the current connection strength is good, so no change in the new connection strength. But if the error isn't 0, the larger the current input value, the more it contributes to the error, and more change is given to the new connection strength during the update, making learning possible. So, multiplying the current input value by the error implies the larger input values trigger neuron firing, contributing to the error, and according to this contribution, we add to the current connection strength to create a new connection strength that reduces the error. Here, the learning rate, by multiplying a very small number, like 0.0001, changes the connection strength very gradually. We'll delve deeper into learning rates in another video, but for now, understand it as a factor that makes the learning process in the artificial neural network gradual. Shall we actually put in the numbers and calculate? Since the current error is 1, we can calculate the new connection strength as follows. Assuming the learning rate is 0.01, the new connection strength W1 becomes 0.308, and likewise, we can calculate the new connection strength W2, which becomes 0.206. Thus, new connection strengths W1 and W2 are determined. These small changes may not seem like much, but with repetition, small changes lead to big changes, so from here on, it's a repetition of the same process. The output becomes 0 again due to the activation function, and since the error is 1 again, the new connection strength W1 becomes 0.314, and the new connection strength W2 becomes 0.215. We update the connection strengths again. Shall we do it one more time? It's a repetition of the same process. The output becomes 0 again due to the activation function, but this time, since the error is 0, the new connection strength remains unchanged. Therefore, when the error is 0, the connection strength doesn't change. Through ample data and numerous repetitions, connection strengths W1 and W2 both will converge to 0.5. We'll explore the significance of this result in the next video. Through such learning, the Perceptron will eventually become capable of predicting the weather with high accuracy. That's all for today's video on Perceptron learning methods. Next time, we'll learn about the limitations of perceptron and multi-layered neural networks. We appreciate your engagement and look forward to exploring further with you in the next session. Until then, farewell. Your interest and love for this channel help a lot in preparing these lectures, so please don't forget to hit the like and subscribe button.